Hi there. Today we're going to look at question number 1 from the 2002 October-November session of the Further Maths Code 9231/1. Question is based on, let us see here, the summation series. Okay, so let's try and see what this question is all about. We have been given that u to the n is equal to e to the nx minus e to the n plus 1 x, and we're supposed to find the sum of un with the limits going from n is equal to 1 to capital N in terms of x. So find this summation here in terms of x and n. Now, the best way to do this is we're going to have to write down a few terms. So before we do that, we take into consideration that the summation of un is simply the summation of the whole expression here. N going from 1 to n, we have e to the nx minus e to the n plus 1 x. And to write down a few terms, I'm going to start off with n is equal to 1. So if I put n is equal to 1 here, I'm going to get e to the x minus e to the 1 plus 1 is 2, so 2x. Add up with, now when n is equal to 2, so I'm going to get e to the 2x minus e to the 3x. It's going to go on forever like this. It looks like an infinite series. So we got 4x now, and then plus so on. Sorry. So finally, we're going to get e to the nx minus e to the n plus 1x. And of course, you can see the pattern. This is going to cancel out with this. The one cancels out with this one here. It's supposed to be 3x, so this is cancelled. This is going to cancel with the next one, and this one's going to cancel out with the previous one. And we are left with e to the x minus e to the n plus 1 into x. Now, this is what they're looking for. We can further simplify this, but it's not really important. Or we could say that it's going to be equal to e to the x. If you factor e to the x outside, you're left with 1 minus e to the nx. So this is basically what the answer is all about for the first part of the question. And what we have then is the summation of un with n going from 1 to n, and so that's the answer. The second part of the question, hence determine the set of values of x for which the infinite series un plus u2 plus u3 plus an infinite terms is convergent, and give the sum to infinity for cases where this exists. Now, what I'm going to do is I'm going to write down the question. It's the second part. Let me just put a second part here, and let's take this one as the first part. So, determine the set of values of x. So we need to determine the set of values of x for which the infinite series, okay, un plus u2 plus u3 plus and so on is convergent. Remember, it is an infinite series, so it's going to go on forever. Now, one of the ways to do this, so if I have to find the set of values of x, I need to understand what's going to happen when this value of n here takes a n here takes a large value. So we're looking at n approaching infinity. Now, as n approaches infinity, we have x here, and we can have x being greater than 0, we can have x being less than 0, but one of them should be taken into consideration for this series to be convergent. Okay, so what I'm going to do is I'm going to try and write down the limits, and so we have this is going from n is equal to 1 to infinity now, And from here, unit un is going to be equal to the sum, and from 1 to infinity, taking our limits into consideration, where we have n, okay, approaching infinity, and the series is e to the x minus e to the n plus 1 into x. Now, if n is large, n is approaching infinity, and let's say we have x being greater than 0. So what is going to happen is that this here, e to the n plus 1 times x, if this has to satisfy those conditions, then this is going also to approach infinity. Why? Because x is greater than 0. You can get the picture. The power x is greater than 0. Let's say 1. And then the constant n is approaching infinity and it's being multiplied. It is added on to 1 and is multiplied by x. So what happens here, this is going to become very large, and this is going to approach infinity as well. So now it doesn't actually converge. So it does not converge. So that means I cannot take x being greater than 0. So if I take x, let's say now we say that n is approaching infinity and x is less than 0. So what happens is we have e to the n plus 1 into x. It's going to approach 0. Why? Because look at this here. When n is less than 0, that means n is negative. If n is negative and it's being multiplied by, x is negative, x is negative, and it's being multiplied by a very large value, we're going to end up with e to the n plus 1. Okay, we're going to end up with, let's say now, 1 over e, because the power is negative anyway. So there's a very large value on top here. So this is also going to approach, it's going to be equal to 0 basically. So as this gets bigger, then it's going to be equal to 0. Now, if this equals to 0, what happens is we have e to the x minus, now all of that is going to become 0. So minus 0. Why is it going to become 0? Because we have these conditions. So the set of values of x for which the sum to infinity, okay, is convergent, right, is then e to the x. So that's the answer. And then give the sum to infinity for cases where this exists. So our sum to infinity is e to the x, which we just gave this, all right? And we gave the set of values of x, okay, the set of values of x for which u1 plus u2 plus u3 plus and so on is convergent is going to be equal to when x is less than 0. Okay, I hope that makes sense and it answers your question. So this is again question number 1, coming from the October 2002 session, code 9231, and this is paper 1, question 1 from the further maths paper. All right, take care, bye.